Welcome to Bedtime Astronomy. Explore the wonders of the cosmos with our soothing Bedtime Astronomy podcast. Each episode offers a gentle journey through the stars, planets, and beyond, perfect for unwinding after a long day. Let's travel through the mysteries of the universe as you drift off into a peaceful slumber under the night sky.
So, picture this scenario. You're sitting on your couch, right? It's a random Tuesday. You're half watching TV, just kind of mindlessly scrolling through your phone's newsfeed.
The usual evening routine.
Exactly. But suddenly, your thumb just stops. Your eyes lock onto this headline in massive, bold letters. And it says something like, strongest hints yet of alien life discovered.
Oh, wow.
Right. Your heart skips a beat. I mean, you're thinking, this is it, the big one. The ultimate question we've been asking since we first looked up at the stars, and it's finally answered while you're just sitting in your living room.
It's a wild feeling.
It really is. But then almost immediately, that skeptical, highly trained part of your brain kicks in. You start wondering, do you actually believe it?
Right. You have to ask yourself what's really behind that headline.
Yeah, exactly. How do you even begin to know what the scientific community as a whole truly thinks about a claim like that versus, what one single highly enthusiastic expert quoted in the second paragraph happens to believe?
It's such an important distinction.
Okay, let's unpack this. Our mission today is to decode what that phrase science says actually means when we're talking about these massive paradigm-shifting discoveries. We want to move beyond those binary yes or no headlines and actually see the hidden mechanics of scientific consensus.
It really is the ultimate modern dilemma, isn't it?
Yeah.
I mean, we are completely surrounded by information all the time.
Oh, drowning in it.
Yeah, but we're often completely starved of the actual context. When a headline drops about something as monumental as extraterrestrial life, we naturally just crave a binary answer. Is it aliens or isn't it?
We want the simple truth.
Exactly. But the reality of how scientists actually process, debate, and eventually accept new data is, well, it's anything but binary. It's a highly structured, deeply conscious process that the public rarely gets to witness.
So let's pull back the curtain on that process because, we aren't just talking about some hypothetical scenario here. We are talking about the reality of what actually happened in the year 2025.
Yes. 2025 was quite the year for astrobiology.
It was insane. We had these two absolutely massive blockbuster announcements that essentially broke the internet. They commanded the global news cycle for weeks. The excitement was just palpable.
The expectations were set astronomically high, literally and figuratively.
Right. So we need to establish exactly what the public was reacting to. Let's start with April 2025. We get this massive news drop regarding an exoplanet called K2-18b. For those who might just remember the chaotic headlines, what was the actual discovery there? Mechanically, what had everyone losing their minds?
Well, the excitement around K2-18b was really rooted in atmospheric spectroscopy.
Okay.
So K2-18b is an exoplanet located about 120 light years away. It orbits a red dwarf star, and it falls into a category scientists call a Hycean world.
Hycean meaning water.
Yeah, exactly. It's a theoretical type of planet with a hydrogen-rich atmosphere and a surface entirely covered by a liquid water ocean.
Oh, wow. An entire ocean planet.
Right. Now, the way we study a planet like that is through the transit method. When the planet passes in front of its host star, this microscopic fraction of the star's light filters through the planet's atmosphere.
Before traveling 120 light years to hit the James Webb Space Telescope.
Exactly. And different chemical molecules absorb specific wavelengths of that infrared light. So by looking at the gaps in the light, the absorption lines, we can deduce what molecules are floating in that alien sky.
So it's essentially reading a barcode generated by starlight.
That is actually a highly functional way to think about it. And so in April 2025, researchers analyzing the barcode of K2-18b reported finding possible traces of a specific molecule.
And this was the big one.
Yes. Dimethyl sulfide, often abbreviated as DMS. They also noted potential traces of dimethyl disulfide.
Which to a casual observer just sounds like, standard industrial chemical.
Yeah, it doesn't sound very glamorous. But to an astrobiologist, DMS is incredibly provocative. Because on Earth, dimethyl sulfide is overwhelmingly associated with biological activity.
Wait, really? Mostly biological.
Yeah. The vast majority of the DMS in our own atmosphere is produced by marine phytoplankton. Microscopic life in our oceans.
Oh, that's fascinating.
It's actually the sulfur compound that gives the sea its distinct, slightly cabbagey smell.
The ocean smell. So the leap in logic for the public was just immediate.
Very electrifying, yes.
Yeah.
If a chemical exclusively made by oceanic life on Earth is found on a distant ocean planet, then, well, there must be oceanic life on that planet.
And the media coverage just took that logic and built a wall of sound. I mean, every major outlet was framing this as an unprecedented advance. The narrative was literally, we found the ocean smell, therefore we found the space whale.
It was everywhere.
But as if that wasn't enough to digest for 1 year, September 2025 rolls around, and we get a completely different yet equally mind-bending announcement. This time, much closer to home.
Yes, Mars.
Specifically, a Martian rock discovered in the Jezero crater that scientists named Chayava Falls. And the buzzword that completely took over the internet for this one was leopard spots.
The leopard spots. I have to say, it's a brilliantly evocative piece of scientific branding.
It really is. So what was NASA actually announcing there?
Well, the Perseverance rover had analyzed the Chayava Falls rock using its onboard instruments, specifically the PIXL instrument, which maps the chemical composition of rocks at a really tiny sub-millimeter scale.
Okay.
And they found what they cautiously termed a potential biosignature. These leopard spots are essentially tiny, millimeter-sized mineral rings found right there within the rock.
And what are they made of?
They consist of a core of iron and phosphate, surrounded by a distinct rim of iron-rich minerals. And again, just like with the exoplanet, we look to our own planet's geological record for reference.
Right. What does it mean on Earth?
On Earth, rings morphologically identical to these are very frequently formed by microbial activity.
Oh, wow. So actual bacteria.
Exactly. Ancient bacteria living in subsurface water use chemical reduction oxidation reactions, redox reactions, to draw energy from the iron in the rock. And the waste product of that biological metabolism leaves behind these distinct ring-like physical markers.
And the rhetoric used at the absolute highest levels of space exploration was doing nothing to tamp down the hype on this one.
Oh, not at all.
I mean, we had NASA Administrator Sean Duffy stepping up to the microphone during a globally televised press conference, and he stated on the record that the Chayava Falls sample was the closest we have ever come to discovering life on the red planet.
Which is an incredibly strong statement.
Right. When the head of NASA says something like that, you cannot blame the average person for thinking we've basically found petrified Martian bacteria.
No, it's entirely understandable. When leadership at that level uses language like the closest we have ever come, it acts as a permission structure. It tells the public to just let their imaginations run wild.
And yeah, it gives them the green light.
Which raises a really fundamental issue regarding how we translate highly technical data into human storytelling. Why do discoveries like the leopard spots or the phytoplankton chemical capture the human imagination so violently?
I feel like it's because it's tangible.
Precisely. It provides a tangible terrestrial anchor. Abstract absorption lines on a spectrograph are incredibly difficult for the human brain to emotionally bond with.
Yeah, nobody's crying over a squiggly line on a graph.
Exactly. But leopard spots conjures an immediate, visceral image of biology. It suggests a living, breathing ecosystem, even if that ecosystem is microbial and billions of years old. The language bridges the vast, cold gap of space with something warmly familiar.
You know, I look at these scientific announcements as operating very much like the modern Hollywood movie trailer.
Oh, that's an interesting comparison.
Yeah, think about it. When a studio wants you to go see a complex 2.5-hour sci-fi epic, they don't use the trailer to show you the 50 minutes of world-building exposition.
No, they definitely do not.
They skip the slow character arcs. They take the absolute most explosive, visually arresting 2 minutes of footage they have. They give you the booming bass drop, the dramatic CGI sequence, and the killer one-liner.
Right, to get you in the seat.
Exactly. The entire mechanism is designed to get you into the theater. But does that 2-minute trailer accurately reflect the pacing and the actual reality of sitting through the entire film? Almost never.
That's very true.
The scientific headlines give us the explosions. They give us the closest we have ever come, quote. But they completely strip away the actual grueling, methodical process of the scientific method.
The mechanics of your analogy hold up very well under scrutiny, I think. The excitement you feel when watching a trailer is genuine, just as the excitement of the scientists who first spotted the DMS signal or the chemical rings is entirely genuine.
Sure, there's real adrenaline there.
There really is. However, the public relations machinery surrounding these discoveries, the university press offices, the media cycles, the frantic rush for engagement on social media.
It's a whole industry.
It is. And it systematically filters out the vital context that scientists actually live and breathe. In a lab setting, a discovery of this magnitude is viewed merely as the starting pistol for a grueling, decades-long process of verification and brutal peer review.
But in the news media, it's presented as crossing the finish line.
Exactly.
And that dynamic brings us to this massive structural illusion that society is currently living under, which is the illusion of science says. You see it constantly, right? You open an article and the very first sentence is, "Science says we should do X," or "Scientists believe they have found Y."
It's everywhere.
It anthropomorphizes the entire scientific endeavor. It treats science as if it's a monolith, like it's a single omniscient entity sitting in a room somewhere, banging a gavel and making objective pronouncements from a throne.
What's fascinating here is that the monolithic view of science is arguably one of the most pervasive and structurally dangerous misconceptions of our information age.
Dangerous in what way?
Well, we have to look at the economic realities of how these stories are produced. When a breakthrough, like the K218b molecules or the Mars spots, hits the wire, science journalists are operating under extreme, often punishing deadlines.
Right, they have to publish immediately.
They have hours, sometimes just minutes, to contextualize discoveries that took decades to make. They need expert quotes to validate the story, and they need them right now.
So what happens?
The structural result of that pressure is that journalists invariably reach out to a small, highly vocal, and easily accessible subset of experts.
I see. They reach out to the researchers who have active social media presences, the ones who are dynamic on camera and who know how to deliver a compelling, digestible soundbite.
Precisely. And we must stress that those individual experts may be genuinely brilliant. Their views, their optimism, and their interpretations of the data might be entirely scientifically valid.
We're not saying they're hacks.
Not at all. The danger is not that they are wrong. The danger is that they rarely represent the complete statistical distribution of thought within the wider scientific community.
That makes total sense.
The fundamental vulnerability in our public discourse is that systematic, empirical evidence about what the broader community thinks is almost entirely absent. We are fed the loudest, most accessible voices, and we mistake them for the collective, integrated voice of the entire discipline.
Right. If a researcher has dedicated their entire 40-year career to the search for extraterrestrial biosignatures, and they're finally handed a microphone, their baseline response is naturally going to skew optimistic.
They're primed to see the signal in the noise.
Exactly. But taking that one highly enthusiastic researcher and framing their quote as scientists believe completely warps the public's understanding of a subject that is probably being fiercely debated in the literature. I want you, the listener, to really reflect on how often you see the phrase "experts say" in your daily reading. We've been conditioned to assume that phrase indicates universal, unquestioned agreement among thousands of researchers in lab coats, all nodding in unison.
When the reality of the scientific method is the exact opposite of that.
Right.
The irony is that these isolated, optimistic quotes inadvertently mask the rigorous, incredibly healthy, and often contentious debate that is the actual lifeblood of science.
The debate is the point.
Exactly. The scientific method does not thrive on consensus. It thrives on targeted skepticism. It explicitly demands that any new empirical claim be systematically torn apart, tested, stressed, and scrutinized from every conceivable angle before it's provisionally accepted.
But the public is shielded from the tearing apart. They don't see the brutal peer review comments, or the failed replication attempts, or the alternative hypotheses.
No, they only see the shiny new claim standing on a pedestal, structurally supported by a few enthusiastic quotes.
So this presents a massive logistical problem for us, the public. If we know we can't trust the headlines to give us the actual unvarnished consensus, how do we measure it? Do we just guess?
That's the million-dollar question.
Do we wait 10 or 15 years for the dust to settle and a new textbook to be published? That isn't feasible when policy and billions of dollars in funding are on the line today.
No, we don't have that kind of time.
Which is where I want to introduce a truly brilliant systemic intervention into this chaotic information ecosystem, because we don't have to just guess anymore. In response to this exact problem, a research group was formed at Durham University known as C-SCOPE.
Yes.
C-SCOPE. It stands for the Center for Scientific Community Opinion Polling and Evaluation. And what they were doing is fundamentally rewiring how we understand scientific breakthroughs in real time.
The architecture of what C-SCOPE is doing is a vital evolution in the sociology of science, really. Well, their methodology was explicitly designed to solve the exact bandwidth problem we're analyzing. Instead of waiting for the historical dust to settle or relying on the flawed proxy of media quotes, they actively measure the community's response while the debate is actually happening.
In real time?
Yes. Within mere days of the K2-18B and Chayava Falls announcements in 2025, the C-scope infrastructure mobilized. They executed a highly structured polling operation, reaching out to hundreds of practicing astrobiologists globally.
Whoa, hundreds of them.
We are talking about geochemists, planetary atmospheric dynamicists, microbiologists, the exact people who study these highly specific mechanisms for a living. C-scope went directly to the source and asked them, systematically and anonymously, to evaluate the strength of the evidence.
Okay, I have to jump in and push back on this concept.
Please do.
Because I can hear the epistemological alarms going off in the listener's head right now. Isn't the entire foundation of science supposed to be empirical facts? It is explicitly not a popularity contest.
That's a very fair point.
Right. If gravity exists, we don't need to send a SurveyMonkey link to a bunch of physicists to make it true. We don't take a democratic vote on whether the Earth is round. So why on earth are we polling astrobiologists about Mars rocks? Doesn't the very act of polling scientists completely undermine the core philosophy that science relies on hard, objective data?
That is a profound philosophical objection. And, honestly, it is the exact correct response when first encountering this concept.
Okay, glad I'm not crazy.
Not at all. You are entirely correct that the established physical laws of the universe do not care about democratic majorities. The mass of an electron is not subject to a public referendum.
Exactly.
But C-scope's underlying operational philosophy relies on a crucial distinction regarding the timeline of knowledge. They are explicitly not attempting to replace hard mass spectrometry data with opinion polls, nor are they treating a majority opinion as an objective indicator of ultimate truth.
So what are they doing?
What they are doing is mapping the territory between complete ignorance and established scientific law. They are focusing on the bleeding edge of emerging evidence.
The bleeding edge, where the data is still raw.
Precisely. At the bleeding edge, the facts are inherently unsettled. The data coming back from a telescope or a rover is often incredibly noisy, it's usually incomplete, and it is intensely open to theoretical interpretation.
Right.
Therefore, polling the experts at this stage does not tell us what the ultimate objective truth of the universe is. Rather, it maps the internal process of knowledge formation.
I get.
It utilizes a concept akin to Bayesian updating. It measures how the community best equipped to understand the raw data is currently weighing the probabilities based on their prior knowledge and the new evidence. It is a systematic measurement of the collective response to profound uncertainty.
I see. So the poll isn't establishing reality. It's acting as a highly calibrated thermometer. It's taking the temperature of the room to see how robust the evidence actually is right now before the textbooks are written.
Exactly. A thermometer is a great way to put it.
When you frame it as measuring Bayesian probability rather than voting on reality, it makes total sense. So let's look at the readout on that thermometer. What were the actual numbers unveiled by the C-scope project for these two massive 2025 announcements?
The results were quite illuminating.
Because the contrast between the media hype we explored in Section 1 and the actual measured astrobiology polls is severe enough to give you whiplash. Let's start with the exoplanet, K2-18b. The media narrative was that this was the strongest hint yet of alien life. What did the actual practicing astrobiologists say when granted anonymity?
The reality check provided by the data was staggering. When the C-scope researchers asked the global astrobiology community if they agreed with the premise that scientists had probably found extraterrestrial life on K2-18b, only 6.6% of them agreed.
Wait, what? 6.6%?
Yes. We must pause on that figure. Only 6.6% of the surveyed experts bought into the core premise that dominated the global news cycle.
That's incredibly low.
Moving further down the scale, nearly two-thirds of the respondents outright disagreed with the claim that life had been found. And a highly significant portion, exactly 28.0%, selected a completely neutral stance, refusing to commit to either side.
6.6%. That is an absolute demolition of the public narrative. If you were just a casual consumer reading the news that week, judging by the tone and the volume of the coverage, you would have reasonably assumed that agreement number was hovering around 90 or 99%.
Absolutely. The disconnect was massive.
Now, what about the Mars rock? Chayava Falls, this was the one where Administrator Duffy explicitly said it was the closest we've ever come. Did the scientists agree with the head of NASA?
The baseline confidence was certainly higher for the Mars discovery compared to the exoplanet, but it remained heavily structurally cautious. For Chaba Falls, 15.1% of the polled astrobiologists agreed that life had probably been found.
Okay, so higher, but still pretty low.
Right. The outright disagreement category fell from the two-thirds we saw with K2-18b down to 44.6%. And the most fascinating shift was in the neutral camp, which rose significantly, swelling to capture 40.3% of the community.
Okay, so let's synthesize that. Even in the highly touted closest we've ever come scenario, with a physical rock showing chemical rings, a combined 85% of the world's experts were either actively saying no or the data is insufficient.
Correct.
That is incredibly sobering. But here's where it gets really interesting, because we have to look past the top-line numbers. If you stop there, you might conclude that astrobiologists are just inherently cynical, dogmatic people who refuse to believe in aliens.
Which isn't the case at all.
Right. To understand the real story, we have to look deeper at the internal mechanics of the data, specifically focusing on the cohort of experts who strongly disagreed.
And that specific metric is perhaps the most crucial, revealing statistical shift in the entire C-scope study. We need to introduce the concept of structured movement within expert opinion.
Structured movement, what does that mean?
In a scientific paradigm, you don't typically see massive overnight swings from impossible to proven truth. Instead, you see gradual migrations along a confidence spectrum. In the case of the exoplanet K2-18b, the proportion of astrobiologists who strongly disagreed with the biological claim was remarkably high. It was 35.1%.
Over a third.
Yes, over a third of the field looking at the atmospheric dimethyl sulfide data and emphatically aggressively rejecting the conclusion that it indicated life. But when we analyzed the response to the Mars rock, Chaba Falls, that pillar of strong disagreement completely collapsed. It plummeted from 35.1% to just 11.1%.
Wow, that is a massive demographic shift, a 24-point swing away from hard, emphatic rejection.
Is a profound movement. The shift from the K2-18b data to the Mars data wasn't a sudden, miraculous jump where everyone suddenly voted yes. Instead, the entire community shifted its center of gravity.
It's often...
They did. They moved from a position of strong, aggressive rejection toward much more tentative, open-minded, and neutral positions. The minds of the experts moved in a highly structured, rational way. And that movement was entirely predicated on the quality and nature of the new evidence.
That feels like the ultimate vindication of the scientific method itself. I mean, it demonstrates quantitatively that scientists aren't just stubbornly digging their heels in to protect their preconceived notions.
Exactly. They aren't dogmatic priests of a certain worldview.
Right. The massive reduction in strong disagreement proves that their minds are entirely open to persuasion, provided you bring them superior empirical evidence. It isn't a binary light switch that just violently flips from no aliens to yes aliens. It's a highly calibrated dimmer switch, and the Mars rock definitely turned the dial up toward the light.
The dimmer switch analogy perfectly captures the nuance of Bayesian probability updating. And as analytical thinkers, we must immediately ask the follow-up question. Why exactly did the dial turn up?
Yeah, what changed their minds?
What were the specific mechanical reasons behind this massive statistical shift? Why was the global astrobiology community so significantly more receptive to the evidence found on a physical Mars rock than they were to the atmospheric data gathered from a distant exoplanet?
I think we have to start with the sheer physical logistics and limitations of the evidence itself. K2-18b is an exoplanet. It is separated from us by 120 light-years of interstellar space.
It's an unfathomable distance.
The evidence we have isn't something we can put in a beaker. It is ancient light passing through an atmosphere, traveling for a century, hitting a beryllium mirror on a telescope, and being computationally translated into a graph of absorption lines.
Very abstracted data.
Chaba Falls, by contrast, is a physical, tangible, three-dimensional rock sitting in a crater on a planetary body right next door to us. It is a rock that the Perseverance rover has physically laser ablated and chemically mapped.
We can touch it, in a sense.
Exactly. And theoretically, through the Mars Sample Return mission, it is a rock we could eventually bring back to a laboratory on Earth and study directly with the full might of our microscopic and chemical arsenals.
The physical proximity and the nature of the instrumentation completely changed the landscape of epistemological certainty. With an exoplanet, you are relying entirely on remote sensing. The signal-to-noise ratio is inherently problematic.
That makes sense.
But even beyond the immense distances involved, there is a fundamental, terrifying hurdle in the field of astrobiology known as non-biological mimicry, or abiotic mimicry.
Abiotic mimicry.
Yes. Astrobiologists are acutely, almost painfully aware that nature is an incredible illusionist. Geochemistry, photochemistry, and planetary physics can produce highly complex, structured, and seemingly lifelike features through completely lifeless, non-biological processes.
So just because a chemical signal looks like life or rock formation looks structurally similar to biology, it doesn't mean it is life. The universe can forge counterfeits.
The universe is exceptionally skilled at counterfeiting. The immense burden of proof in astrobiology is rarely about a failure of imagination. Scientists have absolutely no problem imagining how alien microbes could metabolize and excrete dimethyl sulfide, or how subsurface bacteria could form iron-rich leopard spots.
The imagination is there.
The true challenge, the agonizing, painstaking, career-defining work, is exhaustively proving that absolutely no other natural lifeless process could have produced that exact same phenomenon. You have to systematically rule out every single geological, thermal, and chemical alternative before you are scientifically permitted to definitively say it must be biology.
You know, I'm trying to think of the best way to visualize this for the listener, and honestly, solving a crime scene comes to mind.
How so?
Well, the K218b evidence is like getting a grainy security camera photo from 3 blocks away, right? You squint at it and say, yeah, that looks like a person running from the scene, but the defense attorney is going to say it could be a shadow, it could be a trick of the light.
There are too many other explanations.
Exactly. But the Mars rock is like finding a literal fingerprint at the scene. It's much easier to rule out a false positive when you have the fingerprint in your hand. You can analyze the ridges and the oils.
That is an exceptionally powerful way to conceptualize the problem of resolution and mimicry. Let's apply that directly to the science. When astrobiologists look at the low-resolution, grainy footage of the K218b atmospheric gas, 35.1% of them strongly disagree that it is definitive proof of biology.
Right.
Why? Because they know that intense photochemistry, the interaction of ultraviolet starlight with non-biological gases, can potentially synthesize dimethyl sulfide in trace amounts. Or massive volcanic outgassing could theoretically mimic the absorption lines we associate with DMS. There's simply too many abiotic ways to generate that signal.
So they reject it strongly.
But when they turn to the Chava Falls rock, when they can use X-ray fluorescence to map the exact distribution of iron and manganese in those leopard spots, the strong disagreement drops to 11.1%.
Because they have the fingerprint.
Exactly. They know that ruling out a false positive on a physical rock is a much more achievable, bounded task. They can analyze the specific isotopes. They can look for the exact thermal gradients required to form olivine without life. Skepticism in this field is not a bug. It is the central, vital feature of good science.
It protects the integrity of the field.
It is the necessary filter that protects us from declaring we've found alien life every time a geologically active planet burps a weird combination of gases.
Which brings us to arguably the most fascinating and perhaps the most misunderstood group of scientists in this entire polling beta set. Not the optimists saying yes, not the hardline skeptics saying no, but the vast middle ground saying, I don't know.
The neutrals.
We need to decode this massive neutral response, because 28% for the exoplanet and a whopping 40.3% for the Mars rock selected a completely neutral stance. They explicitly refused to agree or disagree with the claim.
It's a huge portion of the community.
I am thinking about those neutral responses, and knowing what we know about how rigorous these people are, I have to assume it's not just apathy. Astrobiologists don't just shrug their shoulders at the biggest question in the universe.
Definitely not.
If 40% of them are choosing neutral, it has to be a highly calculated position. I imagine it essentially breaks down into 2 or 3 specific camps. It's got to be either the tools we use to measure this just aren't sharp enough yet, or we need a better theoretical framework before we can even evaluate the claim. Am I on the right track there?
You are exactly on the right track. And you've intuitively identified the core epistemological reasons why an expert chooses neutrality.
Okay, good.
Flattening a complex scientific opinion into a binary yes or no narrative is incredibly tempting for the public because it's easy to cognitively digest. But doing so destroys the nuance that is essential for true scientific understanding. A neutral response from a leading scientist is never a shoulder shrug of apathy.
So what are the camps?
In the context of the C-scope polling data, we can statistically analyze that massive 40.3% neutral block and see that it actually represents 3 very distinct, highly considered, and deeply rigorous philosophical positions.
Let's break them down.
The first meaning of a neutral response, as you suggested, with the tools not being sharp enough, is a direct, empirical assessment of the data itself. The scientist has looked at the signal-to-noise ratio, perhaps the overlapping absorption lines of methane and DMS on the exoplanet, or the ambiguous redox boundaries on the Mars rock, and judged the evidence to be genuinely mathematically inconclusive.
So it's just not enough proof.
The data simply lacks the statistical power to sway the needle in either direction. It is a true, objective stalemate of evidence.
They are saying the jury is still out because the prosecution hasn't rested yet.
Precisely. Now, the second meaning involves the scientist's internal confidence interval. A researcher might hold an intermediate level of confidence. They might privately lean slightly toward, yes, this is biology, or slightly toward, no, this is abiotic mimicry.
But they won't say it publicly.
Because as trained empiricists, their internal confidence threshold has not yet been breached. The data isn't strong enough for them to officially tie their professional reputation to an agree or disagree box on a survey. They are strategically hovering in the gray area, waiting for the James Webb Telescope to conduct another transit observation, or waiting for a sample return mission to provide the exact data point that will push them over the edge.
And what is the third camp? The one regarding the theoretical framework.
The third camp is perhaps the most philosophically vital. A scientist might deliberately choose neutral because they regard the entire claim as fundamentally too speculative to responsibly endorse or reject at our current stage of technological evolution.
Oh, that's interesting.
It is a principled epistemological stand against jumping the gun. It is a way for the community to signal the question itself is valid and the data is interesting, but the analytical framework we currently possess is simply too immature to even warrant a definitive answer right now.
Wow, that reframes the entire concept of neutrality for me. So when we see a massive swell in the neutral category, like jumping up to 40.3% for the Mars rock, that is actually a really vital, positive signal of softening attitudes. Even if it looks like a non-answer on a spreadsheet, the intellectual ground is shifting beneath our feet.
It is moving.
The community is moving into a state of active, engaged waiting. But I have to play devil's advocate here on behalf of the listener who actually has to live and operate in the real macroeconomic world.
Go right ahead.
That layered philosophical nuance, that is fantastic for academics debating epistemology in a university faculty lounge. But the public and the government often needs binary answers.
I know, it's a tension.
We use these answers to make massive, real-world decisions. We use them to direct billions of dollars in taxpayer funding. If NASA goes to Congress and asks for $12 billion to fund the next generation of Mars sample return rovers, the Appropriations Committee wants a binary reason why. They want to know, are there aliens or not? How do we possibly reconcile this incredibly complex, shifting scientific neutrality with the public's absolute logistical need for a bottom-line answer?
It is the ultimate tightrope walk of modern science communication, and it's a tension that exists at the heart of all publicly funded research. But the answer cannot be to force scientists to give fake binary answers simply to appease impatient funding committees or media cycles.
Because that ruins the science.
Exactly. If we do that, we corrupt the scientific method itself. The only long-term sustainable answer for an advanced civilization is to advocate for and build vastly better scientific literacy across the whole of society.
We need to get comfortable with the gray area.
We need to teach the public, and crucially, we need to teach our political leadership to be comfortable with and even to actively value the neutral phase of scientific discovery. When 40% of the world's leading astrobiologists say we remain neutral, that should never be perceived as a failure of the discipline.
It's actually a feature.
It should be championed as a sign of incredibly rigorous, healthy, and functional scientific vetting. It means the immune system of science is working perfectly. It means they are demanding superior, irrefutable evidence before they permit you to spend billions of your tax dollars chasing what might just be a geochemical ghost.
I love that phrase, the immune system of science, and I think that realization forces us to zoom out. Because while we've spent this time talking about exoplanets and Martian geochemistry, I feel like we're actually talking about the fundamental architecture of how we handle truth in our society.
Very much so.
Let's pull back from the specific search for alien life. How does this exact dynamic, this dangerous gap between headline hype, perceived consensus, and actual measured scientific reality affect the most pressing terrestrial issues we are facing right here on Earth?
If we connect this to the bigger picture, the implications are profound and immediate. If you take the analytical framework we've just built regarding astrobiology and apply it to the most high-stakes existential fields of our time, you see the exact same structural vulnerabilities.
Like what, specifically?
Look at climate science modeling. Look at epidemiology and the management of global pandemics. Look at the rapid, largely unregulated development of artificial intelligence, or the bleeding edge of genetic editing in medical research. In every single one of these critical domains, public conversations, media narratives, and political debates are constantly invoking the phrase scientific consensus.
Oh, it is everywhere. Scientists say AI will lead to human extinction in 5 years. Experts believe this new dietary intervention prevents all cognitive decline. It is the exact same hype machinery, just applied to different anxieties.
Precisely the same machinery. And just like the alien headlines, those sweeping claims of consensus are terrifyingly frequently based on selective quotations, highly vocal outlier individuals with large platforms, or a fundamental misunderstanding of how the broader expert community actually views the complex, noisy data.
The risks are huge.
The systemic danger here is immense. If political will, and consequently global policy and resource allocation, turns on poorly measured assumptions about what scientists actually believe, we risk making catastrophic, irreversible errors in societal judgment.
So what does this all mean? If we make a $10 trillion decision on global climate mitigation policy, or if we completely restructure our international healthcare supply chains based on what a few loud voices tell us the consensus is, without actually utilizing tools to systematically poll the experts, we are essentially flying a commercial airliner blindfolded.
We are entirely flying blind. We must accept that scientific knowledge inherently and inevitably advances through deep uncertainty, through highly structured disagreement, and through gradual, painstaking, incremental revision.
The neutrality isn't a weakness.
Not at all. The neutral phase, the cautious skepticism, the slow, methodical movement away from strong disagreement, that is not a weakness of the scientific endeavor. That is the armor of science.
That's beautifully put.
Therefore, tools like the Cisco Polling Center and the methodologies they are pioneering are not just neat little academic exercises designed to settle arguments at astrobiology conferences. They are vital, necessary instruments for maintaining a functioning, rational, and empirical society. If we're going to successfully navigate the overwhelming existential complexities of the 21st century, we must structurally invest in systematically finding out what our experts actually think, mathematically and anonymously, rather than relying on what the loudest headline claims they think.
So the next time you, the listener, are scrolling through your phone on a random Tuesday and you see a headline screaming about impending AI doom, or a miraculous new cure for a chronic disease, or yes, the definitive discovery of alien life, take a breath.
Look past the trailer.
Exactly. Look past the explosions and the bass drops in the movie trailer. Ask yourself where the silent, rigorous majority of experts are currently standing. Look for the nuance, look for the methodological neutrality, and recognize that a lack of an immediate, satisfying binary answer is usually the truest sign that real paradigm-shifting science is actually happening.
It takes time to get it right.
It really does. We spend so much of our time and our cultural energy looking up at the stars, desperately hoping for a definitive binary yes or no to the ultimate question of whether we are alone in this vast universe. We deeply want the comfort of certainty.
It's human nature.
But perhaps, when all is said and done, the greatest leap in human evolution won't actually be the moment we find the alien life itself. Perhaps the greatest evolutionary leap will simply be maturing enough as a species to sit comfortably, patiently, and rationally in the quiet, rigorous uncertainty of we don't know yet.
That is a profound and necessary thought to end our discussion on. Embracing the we don't know yet and mapping the exact dimensions of that unknown is the very foundation of all future human discovery. Thank you for exploring the mechanics of this with such curiosity.
And thank you all for joining us on this exploration of truth and methodology. Keep looking up, keep asking the difficult questions, and remember to always read between the lines of the next big headline. Until next time.